Okay, this is the P2 paper from June 2024. It's question number 2, which is a sequences and series question. In particular, we've got an arithmetic series here. It's giving me 2 pieces of information, so I'm going to get 2 equations to solve simultaneously. Let's start off with part A then. I want to work out value of the first term and the current difference. Let's just first of all write down what we know about arithmetic. So for arithmetic series, we know that the nth term is equal to a plus n minus 1d, and we know that the sum of n terms is n over 2, 2a plus n minus 1d again. So those are the 2 formulae I'm going to be using. The 6th term is 2. Well, the 6th term will be a plus 5d, won't it? N minus 1 plus a plus 5d is equal to 2. So there's one equation. The fact that the sum of the first 10 terms is minus 80, well, if the sum of the first 10 terms, that's going to be n being equal to 10 then, so 10 over 2, 2a plus n minus 1, 9d, we know that that's equal to minus 80. That's going to be equation number 2, and now I need to solve these 2 simultaneously. Let's just make number 2 a little bit neater. I've got 5 outside the brackets, so 5 times 2a, 10a, 5 times 9d, 45d is equal to minus 80. And if I do this equation times 10 then up here, I'm going to have 10a plus 50d is equal to 20. So I just need to tidy those 2 up. If I subtract those 2 now so that the a's cancel out, I'm going to get minus 5d is equal to minus 80 minus 20 is equal to minus 100. So that means that d will work out to be equal to 20. And then if I want to work out a, what have we got? A plus 5d equals 2. So a plus 5d equals 2 gives me a plus 100 equals 2. So a is equal to minus 98. So A and D, that's the first thing they asked me for. And then part B, they said, find the smallest value of n for which the sum of n is greater than 8,000. Okay, yeah, done lots of these. So part B, I want the sum of n to be greater than 8,000. And remember, the sum of n is n over 2, 2a plus n minus 1d, so that's going to be greater, than 8,000, but we know a and we know d now. A is equal to minus 98 and d is equal to 20. So if I put those in, I'm going to get n over 2, I don't know what that is, but I do know 2 lots of a is minus 196, and d is equal to 20. I'm just going to put it at the front there to make it a little bit easier when we're doing it. This is 20 lots of n minus 1 is greater than 8,000. And now we just need to tidy this up in as many steps as you need to do it. I'm going to do it quite slowly because obviously I'm doing it for students, but otherwise I might be a bit quicker than what I'm going to do here. I've got 20n minus 20 minus 196 is greater than 8,000. So that's n over 2. I've got 20n, sorry, handwriting, 20n minus 216 is greater than 8,000. So I'm just going to double everything up. N 20n minus 216 is greater than 16,000. If you do it using less steps than me, it's absolutely fine. I'm going to get 20n squared minus 216n. Let's take the 16,000 over as well. Is greater than 0. So I just need to solve this inequality. The way to solve an inequality is to find the critical values. Okay, which now means I can put it equal to 0. So 20n squared minus 216n minus 16,000 equals 0. And then let's just solve that. Using quadratic formula. I might divide everything out first, see if it factorizes. I'm going to get 5n squared minus 54n minus 4,000 is equal to 0 there. And then once I've done that, use a quadratic formula. So I divide everything by 4 there. Use a quadratic formula. N is 54 plus or minus the square root of 54 squared minus 4 lots of 5 lots of 4,000. So we're going to get that N works out to be equal to 34.2, or N works out to be equal to minus 23.4 here. So I can ignore the minus 23.4. N is a number of terms, so that can't be possible. So N has got to be greater than 34.2. So the next value of an integer is that N is going to equal 35. So the smallest value of N, 34.2 would have done it, but that's not a number of terms, whereas 35 is. Okay, hopefully that will make sense to everybody.